Bob Semple tank. It seems that history has taught us two things about tank design. One, never design a tank in haste. And two, never design a tank through a large committee. But the worst case is to do both like the British did with the Tog tank. This was a tank hurriedly designed by the Special Vehicle Development Committee in 1939 to fulfill a need for a superior British heavy tank that was made a top priority as war with Germany was now becoming a distinct possibility. The resulting tank, the Tog 1, was brilliant, innovative, powerful, and lethal if it had been designed and deployed at the end of World War I 20 years earlier. By the standards of 1939, it was outdated and cumbersome, designed for an era of trench warfare, not for an era that now demanded an agile and all-around performer, which could take advantage of the new mobile warfare personified by the German blitzkrieg tactics. At the same time, on the other side of the world, 11,000 miles away in New Zealand, they too were waking up to the possibility that another world war might be on the horizon. When the inevitable happened and Britain declared war with Germany on September 3, 1939, so did New Zealand later that day. Then, when Japan entered into the war in December 1941 with the attack on the USS base at Pearl Harbor, New Zealand came to a sudden and awful realization. In World War I, New Zealand had patriotically sent troops to fight and die for an ideal on battlefields from the Middle East to France. But World War II was going to be a totally different war for the New Zealanders. As Japan had now joined the war, there was a real possibility that geographically isolated New Zealand might be invaded. Right from the start of the war, New Zealand had realized they had a deficiency and need in all categories of modern weaponry, including ships, airplanes, and tanks. And they knew their allies could not necessarily make up these desperate shortfalls, as they had urgent needs of their own. So New Zealand rushed to rearm and upgrade their armed forces, hindered by the fact that they only had limited heavy industrial capacity. So to fulfill the desperate need for combat aircraft, they accepted numbers of obsolete aircraft from their allies, like the Vickers Wildebeest, as well as hurriedly converting civilian DH-86 passenger planes into bombers. At the start of the war, New Zealand did everything they could possibly do to boost their naval strength. This included such desperate measures as converting the passenger ship SS Monowai in 1940 into an armed merchant cruiser and renaming it HMNZS Monowai. But the New Zealand government and military knew that all this might not be enough to deter a Japanese invasion, so they began to face the terrifying reality that they could be fighting the enemy on their own soil. They had foreseen this problem as early as the summer of 1940 after the fall of France. So they had then turned to Bob Semple, the Minister of Works, who was known as a no-nonsense kind of man. He took on the project with great enthusiasm and came to the conclusion that the best approach was to utilize what they already had. So he concentrated on converting existing vehicles rather than building something from scratch. He was not hampered by being tied to a committee, and to some degree he was given free range over the design. Therefore, he chose the basis for his design to be the American D8 Caterpillar tractors, which at the time 81 were available in New Zealand for conversion. The Caterpillar D8 was a proven and popular American track-type tractor first produced in 1935 and ended up being used all over the world in large numbers. The design was so good and versatile that it had evolved over the years, and the most recent version today is the D8T that was introduced in 2004. So it was a sound choice for conversion, and Bob Semple proposed designing conversion kits that allowed the current fleet of tractors to be used in their intended role in supporting construction projects, but could be converted into combat tanks at a very short notice. The concept was indeed ingenious, but when a few test conversions were publicly paraded, it was widely ridiculed by both the press and the general public, and many wrongly thought the bolted-on armor was just normal corrugated roofing. What he had actually created was a tank with 0.31-inch armor plate with half-inch manganese-rich corrugated steel plate welded on, armed with multiple legendary brand light machine guns pointing in all directions and a sturdy commercial tractor beneath it, all with a 127 horsepower engine. It was planned for the tank to have a 37mm gun, however such an armament could not be obtained in time, and instead a Bren gun took its place. All this was readily available, but sadly, this did not make the design any good. In fact, it was one of the worst tanks ever produced. The New Zealand Army referred to it as a mobile strong point, which was a pretty accurate description for what it might be good for. As a tank, it was deficient in virtually every department, apart from ease of manufacturing. The tank was most often referred by the people as the Semple tank. A likely tank the Semple would have met in combat at the time was the Japanese Type 95 Ha-Go light tank, which was the ideal tank to use in an amphibious assault on New Zealand due to its lightweight mobility and its compact size. The Type 95 could easily out-accelerate the Semple tank. It was much faster, capable of achieving speeds of 28 miles per hour compared to the Semple speed of just 7.5 miles per hour. The Type 95 was much more agile, being able to turn on the move, something that the Semple tank could not do. And furthermore, the Semple's agility was hampered by its height of 12 feet, which meant that when it was on bumpy roads or crossing ditches, it was in danger of toppling over. Whereas the Type 95 was much more stable and presented a much smaller target to be fired at, being at just over 7 feet tall, making its silhouette 40% less than the Semple. Even how long it could stay mobile on the battlefield was far less than the Type 95. The Semple tank only had an operational range of approximately 99 miles, whereas the Type 95 could do 30 more miles than that before needing refueling. In armament between the two, it was very one-sided. The Semple had 6 .303 caliber Bren light machine guns, one in the turret, one in the rear, one on its left-hand side, one on the right-hand side, and 2 forward-facing, which was only good for destroying trucks and engaging infantry. But it was an unstable platform. Gunnery was only effective when moving at low speeds on flat surfaces or when stationary, with the added problem that the Bren guns only had 30-round magazines and would need changing constantly during a firefight. The Type 95 was far from perfect when firing on the move, but was better than the Semple and boasted a dedicated anti-tank 37mm gun that would be able to easily penetrate the Semple's composite armor. The designer himself claimed the armor could only withstand anti-tank shells of up to 20mm. The Type 95 also had 2 useful medium machine guns, one front-facing, the other covering the rear of the tank. They would struggle to do any real damage to a tank like the Semple, but it was not what they were designed to do. Their role was to engage infantry or very light armored vehicles. Who knows what would have happened if the Bob Semple tank would have been mass-produced and had met something more powerful like the Type 97 medium Japanese tank, or had been deployed to the European theater and met a Panzer III. Ironically, Bob Semple had said about the tractor tank project, "If this country is going to be invaded, we need to have equipment as good as that of the other fellow, if not better." In that respect, his tank failed miserably, but many, including himself, felt proud of what he had achieved, as they felt at least they tried to do something during their country's darkest hour. Only 3 were ever built, and in 1942 they were converted back to being tractors as the Allies' Valentine tanks and locally produced Bren gun carriers became available and the threat of Japanese invasion had subsided. Maus tank, super heavy tank. The Panzerkampfwagen 8 Maus was a super heavy tank designed by the German forces during the Second World War. This was the heaviest tank ever built in human history. By the end of 1944, only 2 prototypes were completed, so the Maus never actually saw action in battle. The development of this super tank was primarily connected with Hitler's obsession to surpass the Allies in developing heavy tanks, especially the Soviets. The task of designing a tank bigger and more powerful than any other was given to the leading German tank constructor, Ferdinand Porsche. In June 1942, Porsche presented Hitler with the idea of the VK100.01 Type 205 tank, which the Führer approved. This tank was to be 150 tons and was intended to use either a 150mm or a 128mm gun, with an additional 75mm gun and an MG-34 machine gun. The production of the tank hull, turret, and armament was assigned to Krupp, while the assembly was to be constructed in the Alket factory. At the time, the project was officially named the Mammoth, but it was eventually changed to Maus, or Maus. On May 1, 1943, Hitler was presented with a wooden mock-up of the future tank. As he was pleased with what he saw, he ordered a run of 150 Maus tanks for production. Although he ordered the version with the 128mm gun and coaxial 75mm gun, he wanted future models to be armed with the more powerful 150mm gun. The outcome of the final blueprints were 10.1 meters or 33.13 feet long, 3.67 meters or 12 feet wide, and 3.63 meters or 11.9 feet high, and it weighed almost 190 tons. The crew was to consist of 6 men, a commander, gunner, 2 loaders, a driver, and a radio operator. The Mouse's armor was very impressive. The turret had a thickness of 220 millimeters or 8.7 inches at the front and 200 millimeters or 7.9 inches thick on its sides and rear. The hull thickness was 200 millimeters or 7.9 inches at the front and 180 or 7.1 inches on the side. The armament of the tank was equally impressive. The main armament was the 128mm KWK-44 gun. With such a gun, the Mouse would be capable of eliminating almost any Allied tank within the range of 3,500 meters. The secondary coaxial armament was the 75mm KWK-44 gun. In addition, the turret was equipped with a 7.92mm MG-34 machine gun for close combat. Such a heavy tank demanded a powerful engine to move it. Porsche's intention was to use the petrol-electric drive they had used before on their version of the Tiger tank. The petrol engine would operate the electric generator that drove the 24 wheels that each track had. The projected speed of the tank with such an engine was 20 kilometers per hour or 12 miles per hour. The engine system was so huge that it took 2/3 of the entire hull and caused the turret to be put at the rear end. With this design, the driver and radio operator seated in the hull were completely cut off from the turret crew. The Mouse's tracks were proportional to the overall size of the tank in order to give it good mobility. They were 1.1 meters wide or 3.6 feet, and they were supported by a suspension system on each of the wheels. As the size of the tank was its prime feature, it was also its greatest drawback. With a staggering total weight of 188 tons, its mobility was under great question, and that was the main reason why German commanders were not fond of the concept. With a low speed and a high silhouette, the Mouse tank was a big target, especially for the Air Force. The drawbacks of the entire Mouse concept seem to have been obvious to the HWA, the German weapons agency, who protested against the Mouse, stating that it didn't need such a tank, and they just couldn't formulate a tactical plan for it. With such limited mobility, the Mouse couldn't serve as a tank hunter, but it could work as a mobile fortress. Ultimately, the Army canceled the order for 150 Mouse tanks in October 1943. In the next month, Hitler ordered the development of the Mouse to be ceased, and he believed resources could be better used for other projects. Authorities, however, allowed Porsche to continue building their prototypes. The first prototype, the V1, was produced in December 1943. Although it had no turret, it was equipped with a dummy turret to simulate the weight for tests. The V1 had a 1,080 horsepower Daimler-Benz MB509 V12 gasoline engine, which produced a speed of only 13 kilometers per hour or 8 miles per hour. Tests showed that the weight of the tank proved to be a great obstacle. Constructors also realized that the weight of 188 tons meant that there was no bridge in Europe that the Mouse could cross without destroying it. To overcome this problem, the V1 was equipped with a huge snorkel that allowed it to be submerged to the depth of 8 meters in order to cross rivers. The second prototype, the V2, came in mid-1944 and was substantially different from the V1. This version had a real turret installed. The engine was replaced with a 1,200 horsepower Daimler-Benz MB517 diesel engine. The V2 had an advanced electric steering system and a new Skoda gear system. All these elements, however, showed only slight improvements. Prototype tests were being performed at Kummersdorf, near the Böblingen Porsche proving grounds. Tests were marked by frequent engine failures and production delays caused by Allied bombings. Finally, in August 1944, Krupp was ordered to cancel the production of the Mouse hulls and to scrap the ones already produced. This was the official end of the Mouse tank project. When the Red Army units approached the Kummersdorf testing grounds in April 1945, the Germans managed to destroy the V2 prototype. The Soviets then took the V1 hull and mounted the V2 turret on top of it in order to conduct tests of their own. Today, this tank stands exhibited at the Kubinka Tank Museum. The Ratte Mega Tank. In the years leading up to World War II, Nazi Germany conducted a vast number of projects with the aim of developing new types of weapons that would bring them military supremacy over other nations. The majority of these designs, as true innovations in the field of weapons design, were ahead of their time. The Germans called them Wunderwaffen, which translates to wonder weapons or miracle weapons. Some of these were successfully deployed to battlefields, while some progressed no further than the drawing board. Many projects resulted in magnificent machines of war, but many others turned out to be complete failures. The idea of building the largest tank in the history of warfare belonged to the batch of Hitler's wonder weapons. Hitler's army mainly fought on land, and they wanted a tank that would make these land battles easier to win. The main feature of this new tank, its enormous size, surpassed everything made up to that point. In comparison, even the heaviest of tanks would have seemed like toys. Like all dictators of his time, Adolf Hitler was in love with weapons that could show off his military strength. When Hitler was at the peak of his power in 1942, he was presented with an idea to build the largest tank ever devised, designed by Edward Ratte, a director of the famous Krupp Company. Hitler was thrilled. The way he saw it, the tank's hair-raising appearance perfectly matched the image of the German army that he wanted to build. At the time, Porsche had started constructing a 188 metric ton heavy tank called the Maus, which was supposed to be the mighty bellwether of the German panzers. The Maus, however, was nothing compared to its bigger cousin, named the Ratte, or the Rat. The Ratte was part of a land battleships concept that was in research from the 1930s. The pioneering nation in this research was the Soviet Union, with a project known as the TG-5. Their idea was to build a multi-engine-driven tank weighing 1,000 metric tons and armed with a 107mm main gun and 4 sub-turrets. One of the engineers working on the project was Edward Ratte. Upon his return to Germany, Ratte brought his own ideas on building a giant tank. He started working as a director of the Krupp Company, and in June 1942 he was given the opportunity to present his ideas to Hitler himself. The Führer showed great enthusiasm for the project and ordered further design studies. Ratte responded with a series of drawings as a base for the future project designated the Landcruiser P1000 Ratte, or Landcruiser P1000 the Rat. Edward Ratte outlined the weight of the Ratte tank to be a staggering 1,000 metric tons. It was an enormous weight compared to any other tank at that time. The latest German tank coming out of the factories, the Tiger I, was only 54 tons. The Ratte's armament set alone weighed 300 tons. The armor and frame weighed 200 tons, its track and propulsion engines 100 tons, and the rest was the weight of its ammunition and other miscellaneous parts. The thickness of the armor varied from 5.9 to 14.2 inches, or 150 to 360 millimeters. The mammoth weight of the tank was followed by its huge dimensions. The Ratte was projected to be 115 feet or 35 meters long and 46 feet or 14 meters wide. With its gun facing forward, it became 128 feet or 39 meters in length. The height of the tank was 36 feet or 11 meters, which was proportionate to a 3-story building. The Ratte was so huge that it even had its own lavatory system and a vehicle bay to hold 2 BMW R12 motorcycles, while it was projected to have a crew of 41 men. The dimensions and weight of the tank necessitated it to have very wide tracks to provide the proper distribution of pressure on the ground. The Ratte was designed to have 6 tracks, each one 3.9 feet or 1.2 meters wide, 3 on each side of the chassis. Setting a 1,000-ton monster into motion would have been a challenging task, as it would have required about 12,000 kilowatts or 16,000 horsepower to move the tank. The first choice of propulsion was 2 MAN V12 Z32-44 24-cylinder diesel engines of 6,300 kilowatts or 8,400 horsepower, which were similar to those already in use by German U-boats. The alternative was to use 8 Daimler-Benz MB501 20-cylinder diesel engines of 1,500 kilowatts or 2,000 horsepower. These engines were used on German E-boats. Both of these solutions were projected to provide a top speed of 25 miles per hour or 40 kilometers an hour. In reality, it would have been unlikely for the tank to achieve that speed due to the likely suspension and transmission problems. The intended armament of the tank was equally as impressive as its appearance. The Ratte was equipped with several types of guns, 2 of which were the main 28cm SK-C-34 naval guns. These guns were developed in the 1930s to be used on Scharnhorst-class battleships. Needless to say, they were extremely powerful. At a distance of 3 miles, the guns were capable of penetrating armor up to 17.7 inches thick. At a maximum elevation of 40 degrees, their range was an incredible 25.6 miles. As an extra gun, the Ratte was armed with a KWK-44 L-55 anti-tank gun. There are no records indicating whether this gun was planned to be positioned at the front with the main guns or on a separate turret on the opposite side of the tank. Other armaments included an unknown number of 20mm anti-aircraft guns and 15mm autocannons normally used on German aircraft. The frightening size of the Ratte was the feature on which the entire project was based. Paradoxically, this was the project's main drawback. First of all, there was no tank factory in Germany large enough to be capable of assembling such a huge vehicle armed with naval guns. For that reason, a shipbuilding yard would have been required. Just building a prototype tank would have taken several months, using much of the yard's resources and space. This was a luxury the Germans could not afford at the time. Even if the tank was built, putting it into action would have been a logistical nightmare. Because of its massive weight of 1,000 tons, the Ratte could not have been transferred to battlefields by railway. Using its own propulsion at a speed lower than 25 miles per hour, the Ratte would have taken an eternity to arrive at the front. If it broke down along the way, it would have been impossible to tow, as it would have taken another tank of the same size to accomplish the task. Also, because of its weight, the Ratte could not have used roads or bridges without destroying them. The only favorable characteristic was the tank's high ground clearance of 6 feet that would have allowed it to simply cross through a river. In the end, the Ratte might have been considered a mighty tank, but it also would have been a remarkably easy target. The Ratte's thick armor might have been a challenge for the Allied tanks, but not for the Allied bombers. Despite the heavy armor, it could not have withstood bombardments from the air. Being a gigantic and slow vehicle would have made it a perfect target for aerial attacks. The Ratte was a huge, powerful, but ultimately impractical weapon. When the idea of building the tank appeared in 1942, the German industry was already overexerted by the war effort. Spending valuable time and resources on building the largest tank in the world would have impeded that same effort for no significant results. That's why the Minister of Armaments, Albert Speer, canceled the project in early 1943 before it even entered the production phase. The Ratte remained just another of Hitler's great fantasies. As German General Heinz Guderian wrote in his autobiography, Hitler's fantasy led him into the realm of the gigantic. The M1 Abrams, main battle tank. The M1 Abrams main battle tank goes back to the 1970s as a replacement for the M60 Patton tank. The tank's origins start with the MBT-70, or Main Battle Tank 1970, a project developed by the United States and West Germany that would produce a more maneuverable and cheaper vehicle than the M60. Development of the MBT-70 went over budget, and West Germany withdrew out of the project, while in the United States, Congress had to be convinced to continue the project in a cheaper and more simplified form as the XM803. This was still too pricey, and Congress pulled the plug on the project entirely. However, as the M60 became more obsolete for the needs of the modern battlefield, Congress ignited the XM1 tank program. In June 1973, the Chrysler Corporation and the General Motors Corporation were awarded a contract to each design a prototype for the XM1. Chrysler's design was chosen in 1976 for development of the M1, later named the M1 Abrams in honor of General Creighton Abrams. The tank would enter service in 1980 and would be manufactured by General Dynamics Land Systems from 1982, after Chrysler were forced to sell their military division. The crew of the M1 Abrams consisted of a commander, a gunner, loader, and driver. The M1 was armed with a 105mm gun, and its upgraded version, the M1A1 Abrams tank, and then the M1A2, produced from the mid-1980s, features a 120mm smoothbore gun. It can fire a variety of rounds depending on the situation, including sabot and high-explosive anti-tank rounds. The turret contains state-of-the-art equipment, a laser rangefinder, a ballistic computer, a gunner thermal imaging day and night sight, a muzzle reference sensor to measure the gun tube distortion, and a wind sensor. The gunner's seat locks him onto the target, stabilizing his aim, regardless of how much the tank is being thrown around by the terrain. The Abrams can engage and destroy enemy tanks a mile away. Secondary armament includes 2 M240 machine guns, 1 coaxial within the turret, and 1 in the front of the loader's hatch. A 50 cal is also mounted in front of the commander's hatch. The tank protects the crew with special Chabram armor, a British invention which uses conventional steel armor and spaced ceramic armor tiles, effective against modern anti-tank weapons. The M1A1 introduced new armor featuring dense depleted uranium sandwiched in between two steel sheets. Most of the armor details remain classified, so that tank crew security and survivability is not compromised. Inside, the ammunition is kept in armored storage compartments so that it cannot harm the crew if it is set off. An air filter system also protects the crew from chemical or biological attacks. The tank has a low profile and weighs 60 to 68 short tons depending on the model. The M1 Abrams has great mobility using its gas turbine AGT 1500 engine, which gives the tank a performance of 42 miles per hour or 72 kilometers an hour on the road, or 30 miles per hour or 48 kilometers per hour off-road. In 1991, during Operation Desert Storm, the world recognized the M1 Abrams capabilities. The U.S. military would send troops to Kuwait against the Iraqi troops who had invaded and occupied the country. 2,000 M1A1 Abrams were deployed by the U.S. Army and Marine Corps. By the end of the conflict, they had destroyed 2,600 Iraqi armored vehicles. Not one Abrams tank was destroyed by the enemy. The 9 Abrams tanks that were destroyed were by friendly fire or on purpose by U.S. forces if damaged to prevent their capture. The deadliness and quiet operation of the M1 Abrams tank has earned it such nicknames as the Beast, or Dracula, and the Whispering Death. The Abrams continues its service in the present day by the U.S. military, and we'll see a new version, the M1A3, in the future. The last working Tiger tank in the world. World War II. Not many weapons, vehicles, or aircraft of the World War II era have gained the iconic status that the Tiger tank did. It has a reputation that stands to this day. Just to see one of these beasts standing in a museum display is an experience. However, there is one that can be seen in action. It's the last working Tiger tank in the world, Tiger 131, of the Tank Museum in Bovington, England. The baptism of fire for the Tiger tank was in autumn of 1942 on the Eastern Front, when a platoon of 4 Tigers were sent to the Leningrad Front. In December of the same year, the Tigers were sent to the North African Front in Tunisia, where the Germans were trying to stop the Allied offensive. This was where Tiger 131 was deployed. The Tiger 131 came down the assembly line at the Henschel factory in Kassel in February 1943, was painted in Dunkelgelb, dark yellow, and was assigned the serial number 250122. Along with the other Tiger tanks, 131 was mounted on a railway carriage and transported to the port of Trapani, Sicily. Over there, they embarked on Cybele ferries, a motorized raft used by the Germans for transport. The final destination was Tunis, North Africa. Once the tanks arrived in Tunis in mid-March, they had their narrow tracks mounted for transport by railway removed and replaced with wider ones, intended for use on the soft terrain of the desert. Parts that were disassembled for easier transport were then reassembled. The now ready-for-battle tanks were then deployed to the 504th Heavy Tank Battalion of the 5th Panzer Army. Tiger 131 was deployed to the 1st Company, 3rd Platoon, as the first tank of the platoon commander, hence its 131 designation, which was painted red on both sides of the turret. The first task for Tiger Tank 131 and its 1st Company was to reinforce the German positions at the Sfax-Maknassi area. By now, the Tunisian campaign was in its final stage. British and American troops were advancing towards the city of Tunis, the last stronghold of the Axis in Africa. On April 21st, in order to withhold the advance of the British Army, the Germans launched Operation Lilac Blossom. The aim of the operation was to counterattack the British advancing from the region around the hill called Jebel Jaffa. Tank 131 was just one of the tanks that participated in the operation in what was to be a decisive battle. For Tiger 131, the war ended right there and then during the last German defense before the Tunisian capital. Almost completely intact, it would end up in British hands. There's a small shroud of mystery on how this happened, as for 75 years it was believed that the tank was captured on the slopes of Jebel Jaffa, while it actually happened 10 miles northeast of there, on a smaller hill known as Point 174, also known as Gerat el Atar.
.174 came into the center of events after the British managed to defeat the Germans in the Battle of Longstop Hill on April 22nd and 23rd, 1943. The British concentrated their attack on .174 and the nearby .156, west of the town of Medjezelbab. After their attacks were repelled on April 23rd, a new one commenced the following day. .174 was attacked by the 2nd Sherwood Foresters and .156 by the 1st King Shropshire Light Infantry. Both battalions were supported by a composite tank battalion under the command of the 142nd Royal Armoured Corps. The 1st King Shropshire Light Infantry were quicker to capture their objective, but did it with heavy casualties. The 2nd Foresters also had many casualties, but with much more difficulty in seizing the top of .174. On the afternoon of April 24th, the Foresters finally seized the crest, only to be attacked by German tanks in a hull-down position from a distance of 300 yards. The Foresters bravely withheld the Tiger's intense shelling, so then one of the Tigers decided to leave its position and head for .174. It was Tiger 131. Once it arrived on the top of the hill, panic broke out. The tank was fired upon from all sides. Infantrymen were firing bursts from their small arms and projectiles from their anti-tank Piats. Some of the Foresters managed to capture a French 75mm gun and started firing on Tiger 131. Finally, the supporting Churchill tanks of the B Squadron of the 48 Royal Tank Regiment and the Ad Hoc Squadron of the 142 Royal Armoured Corps opened fire from the neighboring hill, .151. In this raining hail of bullets and shells, Tiger 131 suddenly stopped. One of the shells hit the Tiger's gun barrel and ricocheted into the turret ring and jammed the turret. Another shot then impacted the turret lifting lug, disabling the gun's elevation device. Then a final third shot hit the loader's hatch, deflecting shrapnel into the turret. The crew of the Tiger, probably wounded and panic-stricken, decided to evacuate the tank. There was a doubt as to whether it was a shell from the French 75mm gun or from the Churchill's 6-pounder gun that disabled the turret. The latest research by experts from the Tank Museum at Bovington showed that it was most likely the shell from one of the Churchills from .151 that stopped the tank. Even today, impact damage from 57mm shells and .303 bullets are evident on the tank. The Foresters remained on .174 for the next 6 days, along with the captured Tiger 131. On May 7th, the 104th Army Tank Workshop arrived at .174 and recovered the Tiger from the battlefield. After it was repaired and put back into working order, the tank was towed away to Tunis on May 24th, which by that time was liberated by Allied troops. The German cross was removed, and a shield of the 1st Army and the Diabolo of the 21st Army Tank Brigade were painted at the front of the hull. While in Tunisia, it was displayed to King George VI and Prime Minister Winston Churchill, who desired to see this beast of a tank. The captured Tiger Tank 131 was a magnificent war trophy for the British, who decided to transfer it to England. The tank was driven to La Goulette Harbor and ferried to Bizerta on August 3, 1943. In Bizerta, the tank embarked on the SS Empire Candida and sailed to Bonn, from where it was transferred to Glasgow on board the SS Ocean Strength. It finally arrived in the UK on October 8th. In the UK, Tiger 131 started a new life. Before it was taken to the Department of Tank Design in Chertsey, Surrey, it was displayed at the Horse Guards in London and even had a public display tour around the country. The show, however, didn't last long, as experts from the tank department laid their hands on it, subjecting it to thorough examination. The tank was stripped of the majority of the important parts, such as its engine, gearbox, and many others. It was in such a condition that it was ultimately put aside, as by the end of the war an interest in further research was lost. Finally, on September 25, 1951, the tank was handed over to the Tank Museum at Bovington. Over there, Tiger 131 spent almost 4 decades at the museum as a static display until a team of restorers decided to bring it back to life. In a highly demanding project, Tiger 131 was stripped to pieces with the majority of its original parts returned back in place after refurbishment. Some components, such as wiring, were replaced with modern versions, while some had to be completely remanufactured. Its breath of life was an in-working order Maybach HL230 engine taken from another Tiger tank to replace the original HL210 engine that was scrapped by engineers at the Department of Tank Design. Finally, the tank was painted in a proper paint scheme with all the original German markings restored. The end result is the greatest attraction of the Tank Museum, the only fully operating Tiger tank in the world. On the now famous Tiger Days, museum visitors have the opportunity to see in action one of the most famous tanks in history. Tsar Tank, 1915, World War I. Strange tanks in history. With the outbreak of the First World War, the idea of creating an armored fighting vehicle was born as a solution to the static nature of trench warfare. It was the beginning of the age of tanks. These first tanks, even though unwieldy and capricious, paved the way towards the tanks that would become a dominant force on the battlefield. On the other hand, in these early days of tank development, there were also concepts that were completely different to tanks that we know today. One such model was the Russian Tsar tank, an armored vehicle whose name did not live up to its awkward design. The person behind the project was Nikolai Nikolaevich Lebedenko, an engineer who already had experience working for the Russian army. When the First World War began, Lebedenko thought about a weapon that could help his nation win the war against the Germans and the Austro-Hungarians. At the time, it was artillery that was the most dominant force on the battlefield. It was believed that the side that managed to establish the supremacy of its guns would prevail in winning the war. To achieve this, an army had to make its artillery not only powerful, but also mobile. One of the largest drawbacks of the artillery at the time was its poor mobility on rugged and uneven terrain, typical for battlefields of the time. On the Eastern Front, where there were no extensive road networks, this issue was even more obvious. With that in mind, Lebedenko formed an idea to build a gun carriage with wheels so large that it could overcome any kind of terrain or man-made obstacle. If he managed to construct such a weapon and put it in serial production, he believed Russia would be a step ahead of its enemies. In December 1914, Lebedenko approached Nikolai Yegorovich Zhukovsky for help in materializing his ideas. Zhukovsky recommended his nephews, Boris Stechkin and Alexander Mikulin, two promising engineers, to also participate in the project. The team of four were responsible for making the initial draft of the tank. They named the tank the Nitopir, or the Bat, because the model resembled a bat when carried by the rear wheel. The first obstacle was that the tank demanded a lot of funds to be constructed. Lebedenko and his team therefore made a scaled model powered by a gramophone spring to present to His Highness Tsar Nicholas II Romanov. The Tsar was thrilled with the contraption, primarily its ability to climb over several volumes of his books. He spent an hour playing with it like a toy. In the end, Lebedenko received 210,000 rubles from the Tsar to make a prototype of the tank. In July 1915, the production of the prototype began under the overview of Alexander Mikulin. The tank was made in sections and then assembled several miles away from Moscow at the secret proving ground in the middle of a thick forest. The tank was huge. It was 58 feet or 17.8 meters long, 30 feet or 9 meters high, and 39 feet or 12 meters wide. The base that largely resembled a standard gun carriage had one top-mounted central machine gun turret, two gun turrets on the flanks, and one smaller machine gun turret on the belly section. The Tsar tank's most distinctive features, the front wheels, were enormous. They were 30 feet or 9 meters in diameter. They were spiked with T-section rims. The inside of the rim, overlaid with a wooden cover, was pressed against two rubberized car wheels by the means of railway springs. These car wheels, rollers rotating towards each other, turned the big running wheel due to the friction. The rollers were connected to the engine shaft through a pair of bevel gears. If there was a case of the running wheels jamming on obstacles, the rollers activated the safety clutch, preventing the engines from burning out. The rear of the tank was carried by a much smaller steel double wheel. The engines used for propulsion were two powerful 240 h-power Maybachs. They provided the Tsar tank with a speed of up to 10.5 miles per hour, or 17 kilometers an hour. The huge wheels allowed the tank to overcome not only the most rugged terrain, but also trees, houses, and any other kind of obstacles. The Tsar tank was envisioned to be manned by a crew of 10 and armed with guns and machine guns. The top central turret was to house a cannon and a Maxim machine gun, and the belly turret was to be armed with several Maxim machine guns. The turrets on the flanks, meanwhile, were planned to house a cannon each. The draft predicted the weight of the tank to be no more than 40 tons. Once completed, the weight of the tank, however, increased to 60 tons due to the use of thicker metal parts for the hull. Instead of being 7 millimeters thick, the hull now had 10 millimeter thick steel plate armor. The armor at the bottom and the roof of the hull were 8 millimeters thick, instead of the initial 5 millimeter thickness. The added weight of almost 20 tons was considered to be the biggest burden for the prototype Tsar tank. In August 1915, the tank was brought out for testing in front of a group of Army representatives. The tank was controlled by Mikulin and Stechkin. The beginning was perfect. Stechkin ignited the engines and set the tank in motion. The first obstacle, a birch tree, broke like a match under the tank, to the amazement and thrill of all those watching. The problems began just as the tank moved out on softer terrain, and the small double wheel at the back became stuck in the ground. The problem was that the rear wheel carried a lot of weight and had no propulsion. Not even putting the engines in full power could make it move. The big wheels just kept turning, but the tank was motionless. With the tank stuck in the mud, the test ended up as a complete fiasco. Lebedenko and his team didn't surrender. They tried to solve the problem by installing larger rollers and more powerful engines of 300 horsepower. All their efforts were in vain, and the Army decided not to pursue the project. The problem of insufficient power was just one of many drawbacks. The military commission found the construction of large spiked wheels too problematic. It made them extremely vulnerable to artillery fire. Just one salvo of artillery shells could destroy the wheel and turn the entire vehicle into a pile of smoking rubble. Not to mention that the size and position of the wheels in front of the guns interfered with their shooting trajectories. For this reason, all of the guns on the tank had a very limited sight angle. In the end, there was an issue with the tank's complexity that caused a high production price. The cost of more than 200,000 rubles was too high for the military budget of the Russian army. The Russians at the time definitely had no material base for the mass production of the enormous Tsar tanks. All of these drawbacks made the Tsar tank completely impractical, especially because the French and the British had already come up with a more effective tank design, using caterpillar tracks instead of wheels. The Tsar tank remains just another dead-end project. It was abandoned right where it became stuck, on the proving grounds in the middle of the forest. It wasn't until 1923 when it was finally disassembled and turned into scrap metal.